Back for the last section of our DecisionTree Guided Project involving the heart failure dataset from Kaggle. So we're going to do a post-prune tree now. So we've looked at the unpruned and the pre-pruned tree. Let's see if we can improve it a little bit more by using some post-pruning techniques. So what we'll do is post-pruned equals DecisionTree classifier. And what we're going to do is we're going to give it a max depth. This is what we got from the pre-pruning. So these are kind of metrics that we settled on. And we've tailored them a little bit for this data set as we've kind of been learning and iterating through the process. But what we're going to do is we're also going to fit this model to get started. So we'll go fit, and we'll do xtrain, xtrain, comma, y train. Okay, let's run that. Okay, next we're going to look at the cost complexity pruning path. So what we'll do is we'll go path, we're going to assign something to path is equal to the post-pruned tree, and we're going to go dot cost complexity path pruning, and we're going to give it x train and y train. Okay, perfect. So what we're going to do then is we're going to take path is equal to pandas, so pd dot data frame, so we can get a nice looking data frame from this, and we'll give it the path, and then we're just going to take a peek at that path object. So run this, and you can see here we get a quite nice tree that gives us the alphas at each level and the impurities. So perfect, great job. Okay, the next thing that we're going to do is we're going to look at the path, and we'll plot out the CC alphas from this data frame along with the impurities. We're going to set marker equal to 0, so we get these nice little dots, and then we'll set draw style to step hyphen post, so we get this nice kind of stepping pattern. So if we run this now, you'll see here we can see that as our CC alpha, our cost complexity path increases, we're increasing our impurities as well. And so that would be expected, but we can see here that maybe somewhere in between 0 and 0.01 or 0.02 might be an ideal place to prune our tree. So what we're going to do next is we're going to do a loop. So we'll go trees equals a blank list, a common for loop workflow. And then what we want to do is for CC alpha in path CC alpha, so iterating through this data frame here, and we're going to go tree equals decision tree, and then what we want to do is we want to go trees dot append, so we're putting this list of trees, we're adding this decision tree, and what we're going to do is we're going to take the CCP alpha and we're going to iterate. That's the big thing here. The key to this loop is that we're taking the CC alpha from this data frame, and then we're going to use that to fit individual decision trees. So we'll get to see how post pruning of the CCP alpha will give us, or how that will play into our predictability in our model. So if we can see here when we run this, we're going to get trees.append, and we're going to essentially loop through all of the different CCP alphas and go through that. So what we'll do next, I'm going to do a few list comprehensions. So we'll do node count equals to as a list. So we'll go tree dot node underscore count for tree in trees. Okay. So we'll do a couple more list comprehensions. So we'll do depth equals to, and then we're going to do list comprehension. So tree dot tree underscore dot max depth for tree in trees. I'm noticing that I missed this spelling mistake here. Got to make sure we do the plural. Okay, so that's where we're getting our depth and our node count. We'll use this to plot in the section below. Node, and that's my mistake, node count. And then what we're going to do is take a look at our node counts. We're going to plot those out. Okay, here, so we'll plot those. We'll run that line of code and node counts. Where did we get the error? So we're calling it, oh, that's sorry, you got to run this cell up above, and then let's run this cell. And we can see here we get the node count. So as the CCL is increasing, we're decreasing the number of nodes, which makes sense. We're not allowing it to grow as much. So let's copy this line of code and just look at the max depth next. So we call this the depth. And so let's look at the depth of each of our trees. So let's plot this out now. Okay, perfect. So it looks like here kind of choosing 0.005 might be a good setting for our alphas, and we can see 0.005. Before we really start to fall off, we are reducing our node count, but we are not sacrificing if we go up to the cost. If we went 0.005 or right in here, we're not sacrificing too much by reining in our growth with the CCP alpha. So it's important to look at a fully grown tree and then kind of work backwards from that. So we're assigning the same decision tree again, but we're now setting the CCP alpha. We're going to fit it with the X train, Y train. We'll run that, and then we'll plot our, oops, sorry, I got to run this one up above, post-prune tree, and then we'll run this one, and we'll look at that. You see a much smaller tree here, node 1, node 2. Let's take a look at how predictive that is now. Do we build a more predictive model? So we'll put in our scores of X train, Y train, X test, Y test. See that? And then we're adding to our workflow from up above. We're just going to add in our third score for train and test of the post-prune tree. We're adding that to our model list, and then we're putting that into a dictionary, and then we're putting the dictionary into a pandas data frame, and we're assigning the index values to the model list. So let's run that, and we can see here that our training scores, so we did really bad with the unpruned tree. We got a very highly overfit model, and so this would not be very predictive out in the wild. We can see that with the pre-pruning, we got 87 on the train, and then our test was 82.9. A little bit better, but we did even better with the training of the post-prune tree by adding the cost complexity path. We reduced the training score only by a little bit, but we increased our test score by quite a bit. We're almost really in line to what we would expect. A point and a half less on the test score is usually a really good sign. That would be what we would expect, and we would now need to put this model into production to see how well it works out in the wild. Thank you so much for joining me on this guided project, and I will see you for the next one.